Well, Mr. Sams?
Yes.
This is our last podcast of Unit 4. And it's probably maybe the most difficult one.
Maybe.
Yeah, I don't know. So we want to learn today about ionic and net ionic reactions.
All right.
All right. Before we really dive into that, the thing that we want to do is we do want to learn about what it means when we talk about something is ionized.
Okay.
So why don't we watch a short little video clip about that?
All right.
All right. All right, today what I want to talk about is how something dissolves. Now on this SAQ table that we've been seeing, we want to really understand what it means when we say something is aqueous, when an ionic compound is dissolved in water. So here I have some water and I have some salt. So I'm going to put some salt in the water. So when I put the salt into the water, it drops in there, and if I stir it, what's happening is the salt is dissolving into the water. But what's happening to the salt as it dissolves in the water? Eventually, this is going to become a clear solution. It isn't yet, but it will. And we'll come back to this in a little bit. To illustrate that, I have brought a couple of props. I have a salt crystal sort of emblazoned here with the red and the black, where the sodium is the red and the black is the chloride. So it's this. We're kind of like zooming in to this beaker right here and saying, all right, this is the salt. This is when it's in the solid state. And over here, I have a bunch of yellow balls, and these yellow balls represent the water. All right. So I want to sort of mix them together and show you something interesting that happens. All right. So when I put the water into the container, they're all kind of moving around. Now over here in the sodium chloride, the reds and the blacks are all connected to each other, and that's what makes them a solid, okay? They're all connected together, but when I drop them into the water, all right, I drop it into the water like this, actually the yellow molecules start to break it up, and then they start breaking apart, and then they start to mix. Now, the interesting thing is that the red is no longer connected to the black. When it was in the solid state, the red was connected to the black. But when it's in the aqueous state, they're all spread apart. So it's actually sort of incorrect to write NaCl aqueous to say they're connected, because actually in the water, they're broken apart. Does that make sense? Now, we also can talk about, yes it is, good, thank you Mr. Sams. Another way we can do this is we illustrate it with a chemical equation. So if we look down here at the table here, I have salt, sodium chloride solid. When I drop it into water, it turns into sodium ions and chloride ions. Notice instead of saying NaCl aqueous, I write Na positive aqueous and Cl negative aqueous, because it's actually more accurate to say that they are apart, since the black is no longer connected to the red, but actually connected to the yellow. Actually, what's actually going on, if I could illustrate this, is the black is actually surrounded by, 5 or 6 different yellows. All right, so that each black would be surrounded in a pattern like that, if I could get them to all sort of stay. And that would also be true of my reds. My reds would be surrounded by 5 or 6. So the reds and the blacks would not be connected at all to each other. They're actually connected to the yellow waters, if you will. And so each is separated and they're not connected. Hence, that's what we call ions. It has been ionized, broken up. Another fancy word, it's been dissociated. It's not associated with the sodium. The chloride and the sodium are not associated together. They are dissociated and no longer connected. So how does it make sense, Mr. Sams?
It makes sense to me.
So yeah, you're the science teacher. Hopefully, folks, it's making sense to you about how when something dissolves, it breaks apart into its ions.
Right.
Let's illustrate that with a couple of pictures. So this is like what we just saw. Here is the sodium and the chloride. I think the sodium is the little one.
Yep.
This is the sodium and the green is the chloride. So this is what it looks like, and these are each of the little water molecules. That we had them yellow in the video clip. That's what it looks like first, and then secondly, what happens is it starts to break it apart, and you can see the water molecules surrounding the green chlorides. And then down here you can see the water molecules surrounding the purple sodiums. And eventually they would all be separated and dissolved. And so the sodium is not connected to the chloride.
No.
They are separated, right? Na positive and Cl negative, and that's why we write it like we did.
Yeah.
You know? So hopefully that makes sense, and you'll see how that applies to today's lesson. Okay?
Okay.
All right. Now, we want to learn about how to write what we call net ionic equations. Okay. Now here are a set of rules. We're not going to spend a whole lot of time going over these. If you feel like it's necessary for you to write these down, Well,
please
then
do
write
so.
them due. If you just want to follow along the process and understand the process, that's the most important thing.
There's basically 3 steps. The first one is you write down your full balanced equation. That's sometimes called the molecular equation.
And that's what we've been doing all along.
Yep, so far. Okay, and then the next step is you're going to write down the ionic equation, sometimes called the complete ionic equation because it has all of the ions in it.
Okay, good.
Okay. And then you're going to turn that into the net ionic equation. And the net ionic equation is only the things that actually react.
That's correct. So if you needed to copy these sort of rules down and what each of these definitions are,
pause and rewind.
Pause and rewind, okay? Because we're going to just dive in and do a couple of examples. 2 of them, actually. So here is the first example. I want to write 3 things. The molecular equation, the ionic equation, and then net ionic. So I have a double replacement reactions. By the way, this primarily works in double replacement reactions. There's other exceptions, but for the sake of our class, I think we'll just do the whole thing.
Yeah.
What's the first thing we should probably do?
We should make a scratch pad.
All right. You're still going to have a scratch pad. In fact, the scratch pad is even more critical in this than it was previously. All right. So I've got barium, Ba.
+2 charge.
And I'm going to figure out his charge is +2.
Nitrate.
Nitrate is NO3. Now, notice again, I did not bring this 2 down. It's just NO3,
because it's not part of nitrate.
Yes. It's just the fact that there's 2 of them.
Yeah.
And then I have nickel.
Nickel.
Now, I do not know its charge.
Not yet.
We'll have to figure that out. Let's do sulfate, SO4. SO4's charge is -2 from the back of your periodic table.
Okay.
So if there's 1 nickel and 1 sulfate, and the charge of sulfate is -2, the charge of the nickel must be +2. That's not too bad.
No.
So now I'm going to trade partners.
Yep.
I'm just doing what we've already done before. You'll see the additional steps in a few minutes. So I'm going to now trade partners. Barium is going to get together with sulfate now, and that's just going to be BaSO4.
Okay.
Because it's +2 and -2. And the nickel is going to get together with the nitrate, and that'll be NiNO3 2.
Okay.
Again, playing the charge game.
Do you want to balance first, or do you want to see what their states? Okay.
Let's go to states.
All right.
All right. I had that screen here. It is. So I've got barium sulfate.
Nitrate. We need to do the first one.
I think they already gave it to us, didn't they?
Did not, actually.
Okay, barium nitrate.
Yeah.
Barium nitrate is AQ, so there's barium.
Okay.
All right, so let's go back to that. So barium nitrate is an AQ.
All right.
Nickel 2 sulfate. Better work.
I hope
didn't
so.
check this one out.
Oh, we don't have nickel on our table.
Nickel's not on our table. Trust me.
We're going to call it aqueous.
I happen to know that it's aqueous. How I know that is there's a bigger table than what you've got, and actually there's rules that I've learned and memorized. Barium sulfate.
We looked that up on the table. It's a solid.
And then this is an aqueous.
All nitrates are aqueous.
So yeah, so there we go. So the reaction will occur. Now we need to figure out about balancing the equation.
Okay.
Most complex one, maybe the nickel nitrate. Yeah. So if I put a 1 there, then there's 2 nitrates, and there's 2 nitrates here. Oh, that's good. Okay, I got 1 nickel, and I got 1 nickel. I got 1 barium, and hey,
look at that.
It works.
Grand.
I think we're good. So that is our overall reaction.
Right.
So I'm going to actually recopy that at the top here.
Okay.
All right. I'm going to write BA.
NO3.
You know, I'm going to do it. I'm going to do it under here. All right. So there's our reaction. Now, when I do the ionic reaction, you must write everything as an ion except solids.
Yes.
If it's AQ,
you split it up.
Then you split it up. And if it's a solid or a liquid,
you leave it together.
Then you leave it together. So here I have barium nitrate, and it says AQ here, so I need to split it up into its
Now when you do
ions.
these guys, start as far to the left as you can because it's going to take up quite a bit of space.
No, I'm going to start way over here. Now, what I actually do is I like to look at my charge box or my scratch pad, whatever, and I'm going to write BA +2. I'm actually going to write whatever in the charge box, and then I'm going to say AQ.
All right.
Then I'm going to say NO3 -1. AQ. I'm just writing just like a charge box. And now we do have an issue here.
Right.
Is there's 2 of these. And so I need to indicate there's 2 by saying a
big
2
in
in front. Do not put the 2 down here. You don't put parentheses. You put the 2 in front because I have 2 nitrates.
There are 2 individual nitrates floating around in that solution.
That's
just
correct.
like we saw in the video.
Okay. Now the nickel sulfate. I'm going to write the nickel just as it appears here. Ni +2, aqueous. Didn't put parentheses here. All right, plus my sulfate, SO4 -2, AQ. You might just think is I have to go like this, I have to split each of these up. So that makes sense. Then I'm going to make an arrow, and I'm looking now here.
That's a solid, so it stays
that
together.
One, I say stays together because they actually connect in the solution and make a precipitate.
Right.
And since this nickel nitrate here is a solution, we're going to split him up into nickels and nitrates. And so I'll say Ni positive 2. Again, that's the same thing as it is over here. Aqueous plus NO3 negative aqueous.
There's two of them.
And because there's a 2 here, I put a 2 in front here. So this right here is called the ionic equation, or the complete ionic equation, right here.
Okay.
Now, there is one more step. That
Right.
next step is to find the complete,
Nope.
or the net ionic equation.
Right.
Now, you ever been to like a basketball game, Mr. Sams?
Yes.
All right. Now, when you were at a basketball game, what was your role? Did you
I-
play in the team?
No, I sat and watched it.
Sat and watched the game. So when you sat and watched the game, what were you called?
A spectator.
You were a spectator at the game. If somebody is involved in the game, they are not a spectator but a participant.
Yes.
So what we want to do is, it might be this way. If you go to a dance and a couple gets together at the dance, what does everybody talk about the next day?
The couple.
The couple who got together. Not the two couples who didn't get together, right? They spectated, they watched. So what really happened is that at this dance, barium met sulfate, and they made barium sulfate. Nickel and nitrate just watched.
Right, because there's still nickel and nitrate on the other side of the equation.
So they are considered spectators. So in a net ionic reaction, you need to cancel out the spectators. So if you look at 2NO3 here and 2NO3 here, actually let me change the colors, it might make it easier.
So guys, it's a spectator ion if it is an ion on both sides of the arrow. So we have 2 nitrates on the left and 2 nitrates on the right, so they go away. We have a nickel on the left, we have a nickel on the right, so they go away. Now, be careful. They have to be exactly the same.
Exactly.
So they have to be ions on the left and ions on the right.
And to write the net ionic reaction, I'll write Ba positive 2,
Aqueous.
aqueous, thank you, plus sulfate, negative 2, aqueous, makes BaSO4. So what really happened at this, in this little beaker, or at this dance, however you want to use analogous, is that barium met sulfate and they made barium sulfate. Nickel and nitrate are unimportant because they did not get together.
Nope.
Okay? All right, let's do another one, Mr. Sams.
Okay, let's do it.
All right, here it is.
Somewhere.
Coming. There we go.
is. Okay.
Strontium hydroxide. All right, I'm going to try and make my charge box smaller.
Okay.
I'll do it up over here.
Good plan.
I need some space.
All right. Strontium is Sr with +2 charge.
So we have Sr plus 2.
Yep.
Hydroxide is OH negative 1. Back of my periodic table or whatever you got your
Chloric acid.
Chloric acid. So if it's an ic acid, it came from an 8. So this will be hydrogen.
Because all acids start with hydrogen.
Hydrogen chlorate.
Chlorate. So
And chlorate
ClO3
is ClO3
with a -1 charge.
with a -1 charge.
Okay. Yeah, the acid, guys, tells us that it has a hydrogen ion in it. That's where the hydrogen came from.
Yeah, the word acid means H positive, not H, but H positive. All right, so strontium hydroxide would be SrOH2 plus HClO3.
Yep. Both of those are aqueous. You could look them up.
Yeah.
But we're going to just...
You can use our chart, trust us, and you'll have to use the chart, sadly.
Yeah,
But
we're
we
gonna save
we
you
have
some
it
time.
memorized. All right, now we're going to now change partners. So the strontium is going to get together with the chlorate. That's positive 2, negative 1. So SrClO3 2. And I happen to know that also is aqueous.
Look it up on the table if you don't believe us.
Plus, H is going to get together with OH. So that'll be HOH.
Oh,
Now let's look that one up on the chart, though,
Yeah,
Mr. Sams.
okay.
I think that would be important.
good idea.
So if we find hydrogen, here it is, hydrogen hydroxide, it's water.
Hydrogen hydroxide is water.
So that counts as a, well, it's a liquid,
Yep.
right, guys? So
Yeah.
we're talking about a liquid substance right here. So this is your liquid. So that proves the reaction occurs.
Right, because a solid or a liquid formed, it
Yeah.
goes.
Now let's see if we can balance this.
Okay.
Probably this is my most complex, though it's not that complex. I've got 2 chlorates, so I'm going to put a 2 in front here. And that gives me 2 hydrogens. I got
4
one.
hydrogens.
No, it's just 2.
Oh,
There's
you're
2
treating the
hydrogens.
hydroxide The same. Okay, I
There's
guess.
2 hydrogens, and actually, so I've only got 1 hydrogen. Think of hydrogen or water as HOH. So if I put a 2 here, there's 2 hydrogens, and then I have 2 hydroxides. So that's actually the balanced equation.
Yep, there it is.
So this is the molecular equation. Call it the ME. Now let's do the ionic equation. Now in the ionic equation, you will split everything up except for
Water.
water.
Right,
Yeah, I say
anything solid
solids
or a
liquids,
liquid.
and we have a liquid here. So everyone gets split up. So strontium. So I'm going to split the strontium hydroxide up. So I'm going to write Sr plus 2 aqueous plus hydroxide aqueous. Now, notice about the 2. You say, Mr. Bergman, you deal with the 2 here. I write the hydroxide as it appears in the charge box. The 2 then comes out in the front. Plus H positive AQ. Now we've got to, let me write it out. Plus ClO3 negative AQ. Now what do I do with this 2? This 2 multiplies everything.
Everything. So there's 2 hydrogen ions and 2 chlorate ions.
Perfect. And now this is an aqueous, so I'm going to split that up. So there'll be Sr plus 2 aqueous plus 2 ClO3 negative AQ. All right, that's because of this 2 right here. Plus 2, and I'll just say H2O if I want to. Liquid. That's the ionic equation.
Yep.
Done.
Or the complete ionic equation.
Or the complete ionic equation. Is there anything that's exactly the same on both sides?
There is.
What would that be, Mr.
Strontium ions.
So the strontium is the same here and here.
They're both strontium ions aqueous.
So they're going to cancel.
Yep. And the chlorate ions. 2 chlorates, they go away.
So the net ionic reaction will be 2 hydroxides, AQ, plus 2 hydrogens, AQ, make 2 waters, liquid.
Can I get rid of all those 2s since they're all 2s?
Yeah, you could actually say, you could round down.
Just
yeah,
do 1 to 1 to 1.
reduce the fraction,
Yeah.
if you will. Yeah, it works too. But that's how you would do it.
All right.
All right, let's do one more example.
Okay.
All right. Let's make it up. Let's do one more, Mr. Sams.
Okay.
All right, this is kind of a nasty one, but that's all right. All right, first thing, start with the charge box, right?
Yep.
So I've got potassium phosphate.
Alrighty.
So
Let's do
in
it.
my box, put it over here. Potassium is K with a charge of positive
+1.
1. Phosphate is PO4, negative 3.
Okay.
And then the second chemical is mercury 2 nitrate. Now, what's that Roman numeral mean?
The charge, I
So
believe we've decided.
Hg plus 2, and
Yes.
then nitrate is NO3, negative 1.
Okay.
So let's put them all together.
All right. Potassium phosphate.
K3PO4.
Uh-huh.
Now, if you look at the solubility table, trust me, Mr. Bergman, oops, it's AQ, right?
Yep.
And mercury 2 nitrate would be HgNO3 That is also, aqueous.
Don't believe us? Check the table.
You can check the table. And
You-
that's
or you
going
can
to
just
trade
read
the partners. Potassium's going to get together with nitrate. That's easy.
Okay.
1 and 1.
Yep.
That'll be just KNO3. And that's also aqueous.
Aqueous.
And here comes our solid. If we put the mercury, 3 and 2.
Yep. Make them 6.
Make them 6. So that'll be Hg3 parentheses PO4
2.
2. That should be an O. All right.
Mercury phosphate.
And that is a solid. I don't think I want to mess with
No,
mercury
that sounds
phosphate.
kind of nasty.
All right, that's my most complex one, right?
Okay,
so
yep.
I'm going to put a 1 there, and let's do the mercury. I got
Balance,
3 of them over
yeah.
here, so I can put a 3 there. I've got 2 phosphates, so if I put a 2 here, that gives me 6 potassiums, so I put a 6 here. That gives me 6 nitrates. Hey, looky there.
Hey, look at that. There's 6.
So that's our complete equation.
Yep.
All right, now the net ionic. Okay, this is going to be a
Okay.
bear. Break up your AQs. That's this one, this one, this one. But do not break up your solid.
Nope.
So to break this up, now watch how I do this. I'm going to say K positive. Now, how many Ks do I have?
2 times 3.
I have 6. So there's 6 K positive. You know what? Yeah, all right, AQ. Plus, this 2 multiplies the phosphate. So I'll say
2 phosphates.
2 phosphates. 2 PO4 negative 3 AQ plus, all right, I'm going to break this up. I see the 3 in front, so that's going to multiply everything by 3. So 3 mercuries, so 3 Hgs. Now I have to write the charge like I have over
Plus
here.
2.
Plus 2 plus
2 times 3 is 6 nitrates. The 3 in the front and the 2 at the end apply to the nitrate.
All right. So we've got the products done, or the reactants.
Reactants.
Let's do the products.
Okay.
Now this one is an AQ, so I'm going to split it apart. And there's a 6.
6
So
potassiums.
6 potassiums. I still must put the charge in the little AQ here. Plus 6 nitrates. AQ.
Okay.
And then we just one more thing left. Now, what do I do with this?
Leave it together. It's solid.
Why?
Because
So
it's a
just
solid.
Hg3 PO4 2 solid.
Okay.
That is your
Complete ionic equation.
complete ionic equation. CIE. Yeah,
Kind of like pi, but without a p.
there you go. Psi. Now what we need to do is we need to
Get
find
rid of
any
the spectators.
Who is exactly the
I
same on
see
both sides?
6 potassiums on the left and 6 potassiums on the right.
All right, so the potassium can cancel. Potassium here, potassium here. Good, okay. Anything else you see, Mr.
I see some nitrates. 6 of them on the left and 6 of them on the right.
Okay, so now to write the net ionic equation.
Whoops. Oh no.
You gotta be kidding me. Okay, Mr. Bergman just accidentally hit the erase all button, but we can do this from our head.
Yes.
What did we have?
We had the mercury 2 ion left.
So we're gonna have. Didn't we have the phosphate
there
first?
Yes, we do have phosphate
So there'll
first.
be
one
how many?
phosphate.
No, there's more.
No,
than one
you're right.
phosphate.
There were 2 phosphates,
It's gonna be PO4, -3 AQ,
and there were 2 of them.
and there were 2 of them, plus 3 Hg plus 2
Yes.
AQ makes
Hg3.
Hg3
PO4.
PO4 2 solid. So that's the final answer.
Yep.
Just back it up to see where we were canceling because I
Yeah.
accidentally hit the erase
We
button.
canceled all the spectators.
And we're
Whatever
trying
was
to do
left,
it-
we rewrote
this-
as that.
This is what's left because all the potassiums and the nitrates, they all canceled out, which you
Mm-hmm.
just saw. So that's how you do net ionic type equations. Hard stuff, but once you get it, it's not that
doable.
hard. It's
Yeah.
just it's tedious, no
It is.
question. But
and the key here though is just knowing how to write chemical names and formulas using the little charge box, your scratch
yes,
pad.
use the charge
Use the
box.
scratch pad.
This must be use. Use me.
Yes.
All right.